In this video, we're going to be talking about factoring trinomials. Remember, trinomials mean three terms. So in general, they'll have the form ax squared plus bx plus c, where a is the coefficient to the x squared term, b is the coefficient to the x term, and c is a constant. Now remember, factoring is undoing multiplication. So that's the goal here. For example, if I had something like, oh, my marker stopped working. If I had something like x plus 2 times x minus 3. We learned previously how to multiply that out. We'd do x times x times a negative, x times a negative 3, and 2 times x, and 2 times a negative 3. We would combine our like terms. So negative 3x plus 2x would be negative x minus 6. So now we are going to be starting with something that's already been multiplied, and we want to work back to factor it. We want to undo that multiplication and get what was there before it was multiplied. So notice how this comes about. We have the first term being multiplied together, and the last term got multiplied to give us the negative 6. And the question is, how do we get this middle term? Well, that was made up of the sum of the two inside and outside terms, right? So the 2 and the 3, it multiplied to give us the 6, and then they had to add together to give us the negative 1. And that's how we're going to undo this multiplication. We have to look at what would multiply to give us the last term, but add to give us the middle term. So let's look at this. First, we want to be able to identify all of the coefficients. So a in this case would be 1, right? 1 times g squared would give me g squared. B would be 8, and c would be positive 12. All right, and the question is, what would multiply together to give us a times c? So a times c is just 12, right, because that front coefficient was 1, and we'll add to give us b. So let's go ahead and list the factors of 12. So 1 times 12, 2 times 6, 3 times 4, and that's it. Those are all the factors of 12. We want to find the factors of 12 that will add up to 8. Well, 2 plus 6 would give me 8, right? So where we factor this is we have our two binomials that are going to be multiplied together. We know g times g would give me g squared, and the factors that we found were positive 2 and positive 6. And there you go. So we could always multiply this back out by either foiling or the box method or distributing, and we should end up with what we started with. So just to check, g times g would give me the g squared. I would have 2g plus 6g would give me the 8g, and 2 times 6 would give me the 12. So that's the factored form. Now this way that I've done only works if the front coefficient is 1. We'll do another video shortly with where a is not 1. Let's look at one more here. This one looks like a is not 1, but with any factoring problem, you have to start with the GCF. We need to factor out the GCF first. This first example up here didn't have anything in common between all three terms, and this one does. So the GCF of all three terms here would be 3, right? 3 will divide out. Not a k, because the 15 doesn't have a k. But once we take that 3 out, we'd be left with k squared plus 4k minus 5, right? So if I distributed this back through, I'd get where I started. So now, just looking at this term, this factor on the right, that whole expression, I have to keep factoring. So I start with the GCF, and then I try to keep factoring. So a here is 1, b is 4, and c is negative 5. Remember, we want factors of a times c, which would be negative 5, because a was 1, that add up to positive 4. Well, the only thing that multiplies to give us 5 is 1 and 5. Now, because this is a negative 5, c was a negative 5, one of these two numbers has to be negative to multiply to give us negative 5. So I could either put the negative with the 1 or the negative with the 5. But I know I have to add up to a positive 4. So if I want it to multiply to negative 5 but add to a positive 4, that means the 5 has to be positive, so I end up with positive 4. So those are my factors here. And then I can go into my two binomials, and this time it was, let me make some room actually. I want to erase this real quick. Making sure not to forget my GCF that I took out originally. So I've got my GCF, and then k times k would give me k squared, and then minus 1 and plus 5 were the factors that we found here. And now this is completely factored. And it doesn't matter the order in which we write these factors, right? Multiplication is commutative, so this would be the same thing as 3 times k plus 5 times k minus 1. Those mean the exact same thing. Because this is all multiplication, multiplication, I could rewrite these in any order I want. In general, we do start with the GCF and then our other factors. Go ahead and try the ones on the right. Alright, now we're factoring x squared plus x minus 20. I identify a is 1, b is also 1, and c is negative 20. So now I want factors of negative 20, right? A times c is negative 20, that will add to a positive 1. I do not always have to list every set of factors, so over here I listed all the possible factors. As soon as I find the factors, I can stop. For example, I know it's not going to be 1 and 20. There's no way to take 1 and 20 and get it to add up to 1. So I'm going to get factors that are closer to each other, like 4 and 5. Now I know if it has to multiply to negative 20, either it's a negative 4 or a negative 5. I need one positive and one negative to multiply to give me a negative. And I know I want it to add to positive 1. So that means the bigger of the two numbers has to be positive for it to add to positive 1. So now I go into my two sets. I know x times x would give me x squared, and I found minus 4 or negative 4 and a positive 5. Whoops. Sorry about that. Let me erase that line there. And that's the factored for, because there was no GCF and my front coefficient was 1. Again, we could multiply this out to check ourselves. In this next example, same thing. I notice that my leading coefficient is 1, b is negative 10, and c is positive 16. So we notice here that with all of these that have the leading coefficient of 1, it's always going to end up what will multiply to give me the c and add to give me a negative 10. So I want factors of 16. It's going to multiply to give me 16 and add to give me a negative 10. Some factors of 16, 4 and 4, can't get 10 out of that. 8 and 2. Alright, I know that I can get 10 out of this, but I want it to multiply to a positive but add to a negative. The only way to make that happen is if they are both negative, right? A negative times a negative will give me a positive, but negative 8 plus negative 2 is negative 10. So Again, my front coefficient was 1, so I can go into x times x, would give me the x squared, and minus 8 minus 2 would multiply to give me negative 16, and add to give me negative 10. In this next example here, I notice that I've got an x cubed for one thing, and my leading coefficient here is not 1. I have a equals 6, and that makes me stop and think for a minute. I think, wait a minute, I forgot to start with my GCF, because at this point I don't know how to do anything with a 6 out front. So starting with our GCF, which you should always do, but that was just kind of our cue here to really rethink about this problem. GCF of the coefficients would be 6, and GCF of the variables would be x, right? These all have an x in common, and I could divide out a 6 from everything. So I have to do that first. I have 6x. When I divide that out, I'd be left with x squared plus 4x minus 5. So now I have my GCF, and I have to look at what was left. I have to continue factoring, I should say. So here my a is 1, b is 4, and c equals negative 5. And that looks better because I have my a equals 1. So I want things that are going to multiply to a negative 5, but add to a positive 4. The only thing that will multiply to 5 would be 1 and 5. And one of them has to be negative to multiply to a negative 5. And I want it to add to a positive 4. So that 5 had to also be positive. When I continue factoring, I don't forget my GCF, so I'm going to bring that down. And I'm left with factoring this x squared, which I think is going to be x times x would give me the x squared, minus 1, and a positive 5 would multiply to negative 5, but add to a positive 4. And there you go. One last one here. Again, I start with my GCF. I notice that all the coefficients have a 3 in common. They do not all have a's. If I factor out a 3, I'd have a squared plus 2a plus 3. Oops, sorry, plus 2. All right. Now I need to look at the factors here. So a was 1, or the coefficients. B was 2, and C was 2. So I need something that's going to multiply to 2, but also add to 2. Well, 2 is prime, so the only factors of 2 are 1 and 2. And if I made them both positive, that would add up to 3, not 2. If I made them both negative, that add up to negative 3, not 2. So in this case, this factor here, the a squared plus 2a plus 2, is what we call prime. Now they did have it, the original did have a GCF in common, but this factored term is prime. I cannot take it any further. So my final answer is 3 times a squared plus 2a plus 2. I just wanted to put one in here like this so you can see sometimes we can't factor a trinomial. I have this trinomial here, and I can't take it any further. The original did have a GCF that I could factor out, but that was as far as we could go.